it, but I was on the eraser setting, so it went away.
Alright, so the mean value theorem, we'll be doing stuff obviously with that, and then with increasing and decreasing. And oh, we'll be starting to learn about the antiderivative also.
Yeah.
Alright.
It was kind of getting on my nerves a little that, like, for the last antiderivative thing, they didn't, like, almost immediately say the 1/5 part of it.
I'm gonna restart my iPad and see if that makes my pencil work any better.
So what is that? A series of unfortunate events?
It's listening
You
to
get
you,
it?
Josh.
You
Stop.
get it?
Oh, I'm sorry, I don't understand.
I'm sure that's how you feel too.
I'm paying attention.
Alright, so this is just a refresher of the piece of the mean value theorem that we'll be using. The first problems say to state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval. And then it says if it does, find each value of c in the interval a to b that satisfies the equation that's listed here. So
That formula, it's giving chapter 3.
I have no idea what chapter 3 was.
yes, it is. Because
Hate
it kind
that
of looks like a slope formula.
Yeah,
Like the rate of change thing.
Yep.
I don't like that formula. Honestly, I don't think I finished all the problems from chapter 3 because
You have to go back and give them a 0.
I
I'm going to have to go back and edit that.
I legit just didn't know how to do them with those formulas, so like what I was doing wrong. And then once we figured out the shorthand way for derivatives, it's like, oh my goodness.
Yeah, it's like, why would I do the other way now?
Why would I put myself through that kind of mental torture?
No, it's just not connecting at all.
What?
Yeah.
I just wrote x raised to the 2/2. Isn't that just x?
Yes. You need the x to the 2/3.
Plug in Apple Pencil. What? I'm very confused.
Where do you plug it in? You can't.
She can't plug it into
I can't
hers.
plug it into this because it's not the same thing. And I brought my charger and everything in case I need to charge it, and I forgot that little piece, like the adapter piece.
Oh.
Murder. This is so annoying.
So are you just gonna use your finger?
I wonder if I can. Wait.
You have to turn on the function that says to let you draw with your finger.
So much work.
Alright, the first thing we need to do is to take the derivative. What's the derivative of x to the 2/3?
2/3 x to the -1/3.
Yep. And just to be clear, this interval here is a to b. So 0 is a, b is 1.
So a
You're
is
gonna have
less
to
than
whip
b.
out the good old-fashioned pen and pencil.
Oh no, you're gonna copy it over to your iPad later?
Yeah. I'm gonna go grab my notebook super quick. I even saw it and I was like, I don't need that thing.
Well, I mean, she didn't at the time.
She does now.
Poor Virginia, unprepared for class. What a pity.
Yeah.
Yeah, tisk me you.
Pencil,
Whatever that means.
paper. At least it won't lag when I'm writing it.
Oh yeah, Yeah, imagine lagging while you're writing.
Oh, I understand. Okay, so what we're going to do is part A is the part that wants us to state whether the function satisfies the hypothesis of the mean value theorem on the given interval. So basically we're going to replace x with c and then replace f of b and like f of a with their like values essentially. So we've got 2/3 c to the negative 1/3 equals, so basically if we plug in 0 for a, like, no, that's not the right word. I mean, it is, but it's not. If we plug in 0 into the original to get f of a, what do I get? 0. If I plug in 1, what do I get?
1.
So this is equal to 1 minus 0 over 1 minus 0. And this is coming from the formula. So basically 2/3 c to the negative 1/3 is equal to 1. So it does satisfy the hypothesis. So that's technically part A. Part B wants to know the value of c that satisfies the equation. So I need to solve for c now. So I'm going to multiply by 3/2. So c to the negative 1/3 equals 3/2. This would be basically the same thing as 1 over the cube root of c. I can cube everything to get 1 over c equals 27 over 8. If I want c on top, I can just flip the fractions over and get c equals 8 over 27.
When you said do the cubing thing, instead of writing c, I wrote 3.
Nice.
I don't know how I managed to do that, I don't know.
How did you get the 1 minus 0? Like, what were we doing for that again?
So this was the like f of a part or f of b.
Mm-hmm.
So if I plugged in 1 to f, I just happened to get 1.
Okay.
It just happened to be that they gave us the same thing because this was just x to the 2/3. When we get into one that has a little bit more to it, it won't quite be that way, but.
Okay.
All right, 4. F of x equals the absolute value of x minus 1 on the interval 0 to 4. What do we know about this?
What is it, corner? Is that what the thing's called?
What does that mean?
A discontinuity.
It's a discontinuity, which means what? What's the very first line of your mean value theorem say?
Something about continuous at every point and differentiable.
So,
No,
correct.
just no.
So the answer is no. There is a corner where
They're saying where, and then you're gonna write.
I'm gonna say at x equals 1.
Yep, because it's been shifted over
'Cause
to the right.
Absolute values like parentheses. When things are in the parentheses with the x, it goes the
Opposite.
opposite direction of the sign.
Yep.
So you knew it was a corner because of the absolute value.
Mhm.
Okay.
with the shifting thing.
I'm glad you remembered that too.
What would you have said?
Not that.
Not that. I would have just sat here.
All right. F of x equals the ln of x minus 1 on 2 to 4. This is why I said, I don't know why I would have said that we aren't doing anything with logs, because this problem obviously has that.
It was the anti-different derivative stuff that you were talking about.
Oh, okay, yes, that makes sense. We will do that, but it comes later.
Right, that's what you said.
Yes.
Yeah.
Yes, it does.
I was glad that the
Just like we just learned log derivatives before Christmas, right? We didn't learn those in chapter 3 with normal derivatives. Huh?
I was reminding Virginia
Oh.
of log derivatives in chapter 4.
I thought you were saying we did that. I was like, no. Regular derivatives were chapter 3.
Mm-hmm. Log derivatives are chapter 4.
I clearly need to review them.
I just needed to review the A.
So what's the derivative of ln of x minus 1?
Let me think.
We'll call this 1 over x minus 1.
Yes.
Yes.
Times
So it's-
1.
Yeah. So technically, it's the derivative of the ln of x is 1 over x, but it's over whatever's in the parentheses, so 1 over x minus 1.
X minus 1 is u, so
But
it's
the derivative of x minus 1 is just 1, so yes, it is a chain rule, but since it's just being multiplied by 1, we don't need to do anything with that. So then part A, we're going to sub in c for x, so we have 1 over c minus 1 equals the ln of b. So if I plug in 4 for x, that's going to give me the ln of 3 minus the ln, plug in 2 for x, so the ln of 1 over 4 minus 2. What is the ln of 1?
0.
Okay, that's what I was gonna say, but I didn't know.
Sure, it
I
was.
promised that.
I
was
think the
telling-
only reason why I remembered that is because I put it in the calculator the other day for something. And I just remembered.
Bruh, you did what?
I think I had to.
Eta what power is 1?
I was with them all the time.
I don't know. I don't remember how these things work. I just remembered that was 0 because my calculator said so the other day.
Alright, so obviously this right here is just 2. So I have, again, fraction equal to fraction. I can flip them over. So I have c minus 1 equals 2 over the ln of 3. I can add the 1 to get c equals 2 over the ln of 3 plus 1. Now they do take this out to a decimal, so you should, because it wants the actual number of what c is.
I love throwing things on the floor.
Is this still part A that we're doing this?
Technically, at what point does it become part B? Let me see. Wait. Technically, like in here, in between, it becomes part B. Because technically, part A is just saying yes or no, I guess. But, like, you need to set it to see that it's part A.
Yeah.
Like, that it makes sense. So, I usually just say it's short, yeah. As long as you answer all the pieces, it doesn't really matter what's part A and part B, but I don't really write the yes or no unless it's a no. So,
Fair enough. Fair enough.
So how far out do we want to go?
they went to 3. Because, like, their answer says yes, and then it has 1 over c minus 1 equals the ln of 3 minus the ln of 1 over 4 minus 2, so c equals 2.820. So, as long as you have the pieces, it doesn't really matter how you have them, as long as you have them. Oh, boy. Okay.
Oh.
Word problem. All right, number 12, it's a temperature change problem. I'm not going to write out, like, the whole thing. I'm just going to try to write some important pieces here. So it took 20 seconds for the temperature to rise from 0 degrees Fahrenheit to 212 degrees Fahrenheit. That is insanely impressive.
How?
Oh, when the thermometer was taken from a freezer and placed in boiling water. Okay, the thermometer, not like the water started boiling that fast.
Okay.
I was like, that's insane. Like, what?
Like, what temperature is that, whatever kind of heater you have, and, like, why is it so efficient?
Like, maybe a gas stove, but even still, that would take, I mean, you might melt it that quick, but you're not going to be boiling. Like, 'cause that's ice.
Yeah.
Like, 0 degrees Fahrenheit is, like, hardcore ice.
Mine takes forever to boil. Just
Yeah.
regular room temperature.
Let's
I find
see.
it interesting how, like, the boiling point is, like, what's supposed to turn into a gas, right? But it still turns into a gas at a much lower temperature than that.
It's a fair point. I don't know. Explain. Hello?
Hey, are you getting pizza?
Yes.
Are they wanting, like, who is, that? Oh, okay. I'm gonna be giving them, hopefully by the time they leave today, I'm gonna have a little letter for them to take home. So, yes. Huh? Okay, I need to let Jen know because she has to do wills still. Because I didn't take them out and look at them before, but no, she did not tell me that yet. I haven't seen her since lunch, so. Yeah, because I didn't get the names to proof them like I normally do, so yes. Yeah, I'm pretty sure I sent it correctly, but I need to go back and verify too. I have not, because quite honestly, I was just not going to do one because we're doing it so different than normal. So yeah, I haven't done one, and I was debating if I was gonna do one at all, but I don't know. Yeah. 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 Yeah, no, I was thinking about just not, because of us doing it on a Friday instead and it being like between games and stuff. Like most other schools, I haven't ever been given a program when I've been at their homecoming, so I was kind of just thinking about not doing one, but yeah, I just don't have time because I teach 7 classes, so It's just blast from the past, so it's just like a throwback, like 70s, 80s, 90s kind of stuff. So,
I don't teach some classes.
yes, I can do that. Okay, thank you. Bye.
I wonder if our little commentaries got recorded.
I'm sure they did.
Oh, I forgot that was recording. He said, I'm glad I don't teach 7 classes. I said, I'm glad I don't teach 1.
Yeah, I don't know. I was debating if I was going to do a program at all, and
I just don't know when you would give them out. Like,
Well-
people already be there. Some people already be there for the game. Some people, like...
that was the thing, and like I don't want to print like a mass amount of them. I don't know.
I don't know either.
I don't know. Well, I haven't decided.
Maybe, like, you would put them for the people on the court or something. I don't know.
But if I'm gonna do them, I'm gonna just do them for everybody. It takes the same amount of time if I'm printing it for
Like,
16 people or if I'm printing it for,
yeah.
I don't know. I personally, if I get a program handed to me, I chuck it.
Yeah.
Like after the fact. Like it's just such a waste, in my opinion, to do that. Like, I don't know. And I just don't have time. Like I have this other stuff that I'm supposed to be doing that I can't even do yet for Friday night, whatever.
When does it...
So,
It's in between JV and varsity, right?
yeah. So,
That's gonna be running around.
So, if I'm coming to spectate the homecoming, what time should I be there?
you're not coming for the games, you're just coming for like
Yeah.
homecoming.
Mm-hmm.
I mean, I'm probably going to tell people that they have to be here on campus by 6:30.
I'll go.
But it won't start probably till at least 7:30. But I want to see people's eyeballs. To know that they're here, because last year we had a bunch of people that were showing up like 20 minutes before it started, and I just can't do that. So,
Can you see my
I can
eyeballs?
see your eyeballs. Yes, thank you.
What do you mean, unfortunately? How dare you?
Okay. Back to this problem. This will probably be where we stop for today. Just because I need to also print off my quiz for next period, and we should be able to get through the rest of it tomorrow. Okay, so we have this thermometer that's been taken from the freezer and put in boiling water, and it goes from 0 degrees Fahrenheit to 212 degrees Fahrenheit on the thermometer in 20 seconds. So basically what they're asking us to do is explain why at some moment in that interval the mercury was rising at exactly 10.6 degrees Fahrenheit per second. So basically down here I've got the time in seconds. It's going from 0 to 20. Over here I've got degrees Fahrenheit. And this would be 212 degrees. So we're ultimately trying to get to this point here. But it's not something that happens like linearly, right?
Makes sense.
Like it probably at first like is kind of slow, and then it speeds up a little bit, and then it probably like kind of levels off a little bit like as it goes. So it's not like this. It's actually probably something more curved like that, honestly, to get there.
Not gonna lie, I was kind of expecting it to go like the other way, like it'll go up a bit faster, and then once it gets closer to like boiling, it'll start to slow down. But that's just how I imagined it.
It's possible. Either way, the graph makes an arc. It's not just like straight.
May chance.
So we're rising at 10.6 degrees Fahrenheit per second at some point in here. That would have to be true because of the mean value theorem. Okay, so this is f prime of c here. So this 20 seconds, I know that it's happening in 20 seconds, is b minus a. And the 0 and the 212 are the f of a and the f of b. So I plug all this stuff into the mean value theorem and have 212 minus 0 over 20 minus 0 equals 10.6. I guess I could have written it with the f prime of c on the left side, but it doesn't matter.
I'm glad that we don't need like significant figures in calculus.
Yeah. So based on this, by the mean value theorem, at some point, it had to be rising by exactly 10.6 degrees Fahrenheit per, I don't know why I was supposed to write per Celsius per second.
So with the mean value theorem, whatever like f prime of c ends up being is a rate that it has to be changing at some point in
Yes. Yes.
It could be like anything, but that one value has to happen at some point.
It has to do that at some point exactly. It doesn't necessarily even have to happen like only once. Sometimes it can happen more than once.
But it has to occur.
Yeah. At some point, and it could happen over multiple seconds potentially, but
It just has to happen.
yes.
It's inevitable.
Exactly. But we'll pick up with number 16 tomorrow. That's where we're going to start tying in the stuff from the last section with this one a little bit. Kind of each section's going to add a little bit each time.
Just like doing number 16 for that.
These ones are going to be asking us to find the local extrema, finding the intervals on which the function is increasing and decreasing. So none of it's too hard. It's just kind of a process of actually going through and doing it. So we should have no problem wrapping this up tomorrow. These problems are a little faster.